Okay, so I'm going to show you how I made these. Here's this blog post. I said I was going to make a video describing how to make a program. And let's just look at the program real quick. It's in here. Okay, so here it is embedded. And the idea is you can drag this and that you're aiming Captain America's shield. You're going to reflect it off of that wall, and there it goes. And you want to try to hit this thing. And so I missed. Okay, so that's how you do it. Let me scroll up here to one particular point. This. The first thing I need to talk about is how do you detect if the shield collides with the wall. So here's the shield moving. I'm going to say it collides if it's along a line, which means that the shield has no dimensions, but let's just move on. And so the way I do that, there's lots of ways you could do it. I first find the wall. I find these 2 points here at the end, and then I find the distance from this point to the shield and the distance from this point to the shield. If this distance plus that distance is equal to this distance, the length of the wall, then it's there. Well, there's a big helicopter. If the shield was over here, then you wouldn't, it'd be greater than L. Okay. Wait, is that right? Yeah, because I'm using the magnitude. Okay. Okay, so let's skip over to the program and see how this works. So this is in GlowScript. Let me move over here. And the first thing I did was make 2 functions. So this first function just checks and sees if the shield hit the wall. And then the second function down here just reflects it, makes it bounce. Okay, so the first thing I need is I have 4 parameters that I pass to this function to check and see if it got hit. R is the position of the shield. WC is the position, the center of the wall. W axis is the axis of the wall. So when you define a object in GlowScript, if you define a box, which I'll show you down below, the axis is a vector that points through the center of the box, and it's perpendicular to one of the sides. L is the length of the wall. Okay, so I'll get into that in just a second. So the first thing I do is create a vector z hat. I don't know why I did that. Okay, z hat. This is a 2-dimensional problem. So this vector z hat is just in the z direction. And so what I can do then is take the cross product to find this point P1. I take the cross product of the axis of the box and z hat, and that will give me a vector along the wall. Okay, so remember the axis is perpendicular to the wall. Z is in the z direction. So axis cross z gives me a vector along the wall. And then if I do it the other way, and then I multiply by L over 2 to give me that distance, and then I add the center of the wall right there to find the new location. Then I do the same thing for the other one. I just switch z hat and w axis. And then I calculate, this is, you don't need that line there. And then I calculate those 2 vectors, R1 and R2. And then I say if the magnitude of those is less than, it's never going to be equal to L. I mean, it might be. But I want it to be if it's close. Okay, so I just have this L times 1.001. You can try changing that. And then it returns true if it does hit. It returns false if it doesn't. So this function, if I give it these parameters, it should say true or false. Is it hit? True. Is it or false? That's it. Okay, now for the bounce, I want the velocity and the axis of the wall. I'm going to say it bounces. Okay, so I need to reflect that. So this alpha t, this is a temporary angle. This is the angle between the velocity and the axis. But I really want this reflection, this incident angle, so you can play with some geometry, and I think this is it. It works at least. Okay, so negative pi minus 2 times that temporary. Now that's the angle between the incident and the reflected angle. So I can just use the rotation matrix, which is what I have right here, to find the x, y, and z components. Well, the z component is 0. So that's just the definition of the rotation matrix. Okay, so now those are those two functions. Next, I have drag equals false. I don't even know what that means. Okay, this stuff right here is important to let you drag that one arrow to set the velocity. So let's run the program and see what I'm talking about. So here, see this arrow, this is how I aim the ball, the shield. Okay, so you need to be able to click and drag that. And this is something that I always forget how to do. So I have to look it up in an old program or something. So here I define a vector. This scene.bind mouse down. This says when you click the mouse down, it essentially does a couple things. Global drag. I'm not even sure what that means. I'm not even gonna pretend. It means something. Yeah, I'm not really sure about this stuff right here. I just know that it works. The important, you can just copy it just as it is. The only thing you need to know is this. You don't really need to know anything. That just says if you are, listen out for a click and drag or something like that. Okay. We'll get to that in a second. Here's the things I make: the target, the shield, the start button, attach a trail. Here's the wall. It's a box. Okay. And then you can print out the axis just to see what it looks like. But I also want to, I don't want a simple wall, so I rotated it a little bit. This is the rotate function in VPython. Okay, aim is that vector that I start off with. I just started at some position, I think. No, I don't even use that. R is the arrow for aiming. Okay, so now let's get down into here, and I'll flip back up. So if you're dragging, then I've assigned this variable R as a vector to where you're pointing the mouse. And then I assign the axis of the arrow to that direction that I'm pointing the mouse. Okay. So let's just run this and I'll show you. I can go over here. I think if I click, it just automatically goes over there. You see, I don't even have to grab the arrow. I can click wherever I want. And then as long as I'm holding it down, it sets the position of the axis of that arrow to wherever that normal position of my mouse is. So that's what this does. And then this temp equals true. Temp equals true. I'm not sure what that's for. Why did I put that there? If the temporary and it not drag. This just says if drag. Okay, so I set this temp equals true to now throw the shield, right? Because now if you drag it, then temp is equal to true. And so if it's been dragged and I'm not dragging it, then I get rid of the arrow, turn to false. I get rid of that starting thing, and then I just move the shield. Now I need to go down here. Oh, it's not scrolling. And then I just do two things. I check if the shield hit, and if it does, I bounce it. And then I check if it hit the target. And if it does, I change the color of the target. And that's it. Okay. So you can play around with this. You should be able to see the code. You can, of course, you can do this. It hits it. You could put a reset button in here or something like that. Fancy, of course. I'm not that fancy. I just wanted to get it to work. So, okay. That's the program. Talk to you later.